Hello. Hi everyone. So I am Rahul Saxena, and I am from the zkSync protocol security team. And today I'll be presenting to you Crypto Sentry, which is basically a nice name to tell you what we actually do. So this presentation is basically as a response, as a method to answer someone who asked me some time back, like why do we need in-house security team when you already have auditors and like you guys still do bug bounties and smart contract audits, then what is the work of the in-house security team? So that's a really nice question, and that's why I wanted to just bring out some of the things that we do and some of the things that other protocols should look out for once they get to some certain size. And yeah, let's go. So this is me. I'm Rahul Saxena. I work at the zkSync team. Current job involves security of zkSync stack, the entire thing, and that has a lot of things going on. For example, there's the compiler, there's the consensus mechanism, there is transpilers, assembly, smart contracts, bootloaders, stuff like that, and circuits, of course. So yeah, the security team has to ensure the security of everything. So that's the first thing. Uh, Earlier, I used to work independently, have been a developer in an earlier life, and on my socials, like if you want to connect on socials, I usually have this surname, this username, Saxenism. So yeah. So let's just start with the rapid fire round of what I could think of as the tasks for the security team, of a in-house security team. So first of all is threat modeling. Second is security focused design review, continuous security focused pull request reviews, security focused code reviews, security championing. This is basically convincing the developers to use something that you want them to use but will take up their time so they don't want to use. Uh, Embedded security engineering, trusted slash sensitive component development, yada, 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 yada. So these are a few of the things that we actually do inside of the protocol security team at zkSync. And if any of this does not make sense, let me know. There are a couple of other things, which is in the next slide. So basically, I really liked that engineer presented before me because he pitched in the idea that security goes beyond security audits. This is what lies beyond security audits. This is it, basically. And if you see again, there is generating invariants for a given system, improving security testing coverage, security specification writing, designing review security tests, so on and so forth. So yeah, a lot of stuff. And again, we can do it because we have a lot of context. Like this is everything we drink and breathe and eat. So we understand what kind of security is required by us, what kind of submissions that we are getting are valid or not, what kind of prioritization that we require in our security right now. So that is pretty much it. And now let's discuss what are the kind of challenges that the in-house security team at any protocol faces. And like, it will be a little personalized to zkSync, but let's go. So the first challenge that we face is usually people consider testing to be boring, right? They do not want to write test. They just the issue with the enforcing testing is that you can at most ask people to have 100% line coverage, something probably around branch coverage as well. But it is very easy to game that metric because you can just call every line, not really check what it is doing, and it will show that hey, we have 100% coverage. So rather than quantitative metrics, you need qualitative metrics for testing, and that is hard to enforce. So you need to bring in a culture basically uh, that makes people enjoy testing basically. Like they should not have egos attached to their code that hey, if the test breaks my code, then that's bad for my ego. That kind of stuff should be done away with. So Web 2 understands this problem deeply, and they have positions, separate positions called QAs and SDET. SDET is a software development engineer for testing specifically, and their literal job is to break the software that they have been given. And Web3, I think, is not at that level of maturity, or there is just not that amount and the quality of talent here. So we do not have it, and we just ask the person who has written the code to test their code as well, which is bad because it has a lot of problems, which we'll come to again later. So yeah, if the developer themselves write the test, it is almost guaranteed that blind spots will persist. So I don't know if you have experienced this or not, but if someone has written their code, they had some logic in mind, something in mind, and they obviously missed some corner cases, some edge cases. So it's not the it doesn't happen that when you ask the same person to write test as well, they'll test that edge case or the corner case that they missed in the code, but they will test it. It doesn't happen. So the same blind spots that exist in the code will exist in the test cases itself, because the same person is writing the tests. And that's why you have like special positions called QAs and SDETs in traditional software engineering, because those guys are like wild. They just test out anything via any manners, and just, yeah, it's just full chaos. But that's good. That's their job. Second issue is testing is hard. Testing is hard is a very subjective statement, but I'll explain what hard means in the context of zkSync at least. Okay? So in an ideal world, given a programming routine, if you could think of all the edge cases and test them along with the normal input range, you would have a bug-free software. Does that make sense? Like, if I give you a piece of code and you have all the inputs that can go into it, plus the edge cases, and you test them out, and they're correct, then the code is bug-free, right? That's correct. And even for a simple piece of code, that is a tall ask. Like, how do you ensure that you have covered all the edge cases, right? But yeah, like, you can be fairly certain, but never fully certain. Now, imagine that you have to test your bootloader. Bootloader is a part in the zkSync engineering stack, which basically gives you access to system contracts, like things that the normal users should not be able to do, stuff like that. So now imagine that you have to test your bootloader, which is a part of a system that contains circuits, L1 contracts, L2 smart contracts, system contracts, custom era VM, not the EVM, and interactions with the consensus layer. So to test this, you have to have mock data that is coming out of all these particular all these particular systems, and you have to be able to accurately get those mock data, and those mock data should be dependent on each other. For example, if a mock value getting out of a circuit is like X, then the value from the L1 smart contracts cannot be Y. It should be a function of X. So that's why it's hard to test system as well. Like, it's hard to test system in isolation that work as a system. So yeah, that's another challenge. Realistic mocking of the values of the system so that you can test out your small part is extremely hard. By the way, so far, anything does not make sense, just let me know. I'll happy to talk. So this is another challenge that I think this is one of the biggest challenges that we face. Engineering decisions are made in silos. So when you have a company like zkSync, which has all these divisions, a crypto team, a compiler team, a consensus team, a protocol team, I mean, a lot of teams. So stuff happens, and people just don't know that it happened, like in the same company. So it's simple to think that you hire the best engineers and you get the best product, but reality is a little bit more nuanced. So the compiler team engineers are experts at the compiler stuff, and the crypto team engineers are expert at the cryptography stuff. But both the teams take engineering decisions based on what they feel best, right? Like, if I am in the compiler team and I'm faced with two decisions, I'll go with what feels best to me as a compiler engineer, and something that makes my compiler better. That's logical. However, many a times it is discovered that a much more optimal decision could have been taken if one team was aware of the capabilities and constraints of the other team. It is quite possible that because of the changes, the optimization that is done in the compiler, Now the Era VM team, the virtual machine team, has to make a lot of changes to their own code because the compiler has changed now, right? So it's all a part of a moving system that works together in synchronity. And these are engineers, and they try to do their best to build their best product, but there is a huge communication gap, and that is hard to fill because it is very deep down in the trenches. Like, it's very hard for a compiler engineer to explain to a consensus engineer that the changes that he's going to make, what kind of upwards impact it would have on the consensus layer, right? It's very hard for them to explain it, and that's where we chip in. I genuinely think of the security team as like more like technical cheerleaders and like salesperson. We just go talk to different teams and we understand what they're doing, and then we go to talk to different teams, and then we say that, hey, they're doing this stuff, probably you should not go that way, probably you should go this way, so that there's more harmony and synchrony between the different moving parts. So yeah, that's why the security team has to act like a bridge between these distinct islands of excellence. So every team in zkSync is like super, super good. Like, they are the best of the best engineers, but they need to have communication between them, and that communication, that bridging between the thoughts and ideas is done by the security team. Okay. Filtering the bug submission spam. So as you might know that we have a lot of bug bounties and audit competitions and whatnot, right? And audits itself. So we receive a lot of submissions, and the thing is that almost all the auditors and white hat hackers that audit one of our systems require a lot of context. And when I say submission spam, I do not mean that it is malicious on the part of the white hat itself. I just mean that because they are missing a lot of context, they do not understand how this particular smart contract is going to affect the compiler and the particular circuit and the consensus layer, the bootloader, stuff like that. So they take an approach where if they feel something off, they just report it, and they go via like spray and pray mechanism. Like, they just tell you that, hey, maybe something is wrong there, then it's your job to actually see whether it actually is wrong or there is some protection against this thing happening in the downstream or upstream components. So yeah, so a lot of submissions are the spray and pray kind of submissions which might look valid even to the engineering teams. Because the engineering teams worked in a silo, they don't really know that if they have protection against this. So, but since we have a Hawkeye view of the system, like the security team have a Hawkeye view of the system, we can accurately assess that this particular fault would be caught at this level and so on. So just as an example that if you, a question that might be in your mind is that why does zkSync even have a VM if you work on circuits? So the reason for that is very simple, that to generate proofs and aggregate proofs, it requires an hour or so, and you do not want that amount of time being spent by a user who wants a transaction fast. So we have implemented the EVM as circuits. That's true, that's what a zkEVM is. But we have also implemented the EVM, in Rust, which emulates what the circuits does, and that is the out-of-circuit implementation. So when you spot some anomaly between the out-of-circuit implementation and the in-circuit implementation, that does not usually means that it's an error. It's basically the system of the, a function of the language that it's written in. So again, that's why the people who have written the Era VM, the virtual machine in Rust, they do not really know what's going on in the circuits that are written in Boojum. And the Boojum guys seriously do not have any idea what's written in the Era VM. So that's one example of how this thing happens. So yeah. I'm really interested with this. Can someone tell me what they think of this type 1, type 2, type 3, type 4 battle that goes on online, that, hey, type 1 is better or type 4 is better? Like, what are their own opinions about this? Like, is type 4 good, bad, worse, type 1? Like, what, anything, if anything, at all? Okay, not you. So, okay, can someone define what a type 1 and type 4 zkEVM is? Okay, I should have put a definition slide. Anyway, so it's basically a spectrum of the EVM compatibility of your zkEVM. So shout out engineer. So basically it means that a really idealistic zk EVM that is of type 1 should be able to take the opcodes generated by the EVM itself and be able to prove those opcodes, right? What makes a zk EVM not type 1 is that there are certain things that you cannot prove on chain. That is why you transpile it to something else, or you convert it into a different format and you prove that converted thing into proofs and submit it on chain. And that is what separates you from type 1. So the lesser amount of conversions and the proof of that conversions you have to do, the more you're closer to type 1. And the more amount of conversions you're doing, the higher you go on the scale. So type 4 is basically people who took the approach of, hey, I want to build a zk EVM, I want to build it in the most optimized fashion. So I will just take the EVM opcodes and convert them in a format that is cryptographically the fastest, right? And what type 1 people did is that, hey, we want to stick as close as possible to the EVM ecosystem and the EVM ethos and whatever. So we'll try to prove whatever opcodes that we get from the EVM. So that's the difference. And zkSync is a type 4 zk EVM. And what that means is that since you do not have the constraints of the EVM opcodes, so you are not constrained by that fact that you have to prove all the particular opcodes. That means you can onboard the best talent on the planet for cryptography to work for you. And you are not constrained by anything whatsoever, because you are just converting it into the format that suits your proving system the best. And while that helps you create fundamentally brilliant academic breakthroughs, that is at least what enables the cheapest L2 transaction fees for us. It also means that you have to undertake a lot of engineering efforts to develop the dev tooling around your novel solution. So to really understand this point, you have to push back to like 3 years ago, when zk EVM was not a solved problem. It was a problem, it was just an idea in people's head that, hey, what if we can just prove the entire EVM, right? So then people were not thinking like, how do we make it the most EVM compatible, stuff like that. People just wanted a POC out there. People just wanted to make it happen, like, because at that time it was not even a guarantee that it would work. So the approach that zkSync took, especially because they were the earliest in the space, was that, hey, we would want to work on this succinct cryptography, or the cryptography that works on blockchain, and we'll figure out the EVM part later. And that is what they did. And that enabled them to move faster, become the first zk EVM, have really cheap cost, have really nice compact algorithms working for their zero knowledge proofs. But that also made them incompatible with a lot of other dev engineering tools that exist right now. For example, if you want to use Foundry, we have zkSync Foundry. Very late down the line, the Remix integration came out for zkSync, because Remix could not run zkSync out of the box. And again, specifically because people who are into zk, as less they are, they still understand things like Circom, Halo 2, Groth 16, Plonk, whatever. But our proving system, which is Boojum, that is even more customized, so that even reduces the circle of people who can audit our code bases and understand our code bases even more. So the kind of people that can work with our systems is extremely low, because it's customized. Everything is customized, nothing is standard, and the only goal was to have the most fastest and most performant EVM. So that's the trade-off that we made. And it has its benefits, and it has its costs. So that is the reason that we have signed a massive educational initiative with Cypherin, so that they educate people about what Boojum is. Because you do not need to teach people what Circom is, because everyone will teach each other what Sarcom is and how Sarcom works, because Sarcom is a common language. But if you want to be working with the Booj improving system, we have to take that initiative to spread the knowledge, because that's just us. And no, if okay, leave that. Any doubts so far? Any discussion points? I'm open. Feel free to just raise your hand. Okay. The 10x dev dilemma. So again, this is something that I hinted towards in the last presentation on Rust Summit. And the issue here is that this is one of the persistent challenges we have had in the company, is that when you are at the beginning of the company, your product does not work, your idea even, like you're not sure if even the idea is worth it or not, then you hire a cracked dev who just comes along and codes throughout the day, throughout the night, and in a week or so you have a POC. And that seems magical, and that is because no normal dev could have done it, but they come along and they do it. So they are a 10x dev, like heck, they're even a 100x dev, if you ask me. So the issue with that is, those people kind of achieve a status of a demigod within that organization because they are that good, okay? And once that happens, and after the product becomes slightly mature, you need people that should be able to keep that 10x dev into a check, into like some technical checks. Like, it should not be the case that whatever this dev says happens. Like, there should be healthy debates, there should be healthy questioning that, hey, why do you think that is the case? Or, hey, I do not think that is safe, that should not happen. That becomes difficult if you have this kind of dev, okay? So the very thing that got you in front in the beginning is something that is hindering you as soon as you become slightly mature. So over time, I've realized that being able to find bugs in a given code base is the base level of skills required to be a security engineer. I mean, coming from a background of independent security research, I thought that being security engineer is just, you're given a code base, you find bugs in a creative way, and that's it. But once I started working in an organization, I realized that it's a given. Like, that is duh. There are multiple skills you have to stack on top of that to be able to do things that you need to do. For example, you have to be able to navigate people's egos, teams' preferences, and schedules, and habits, and visions, and politics to be able to implement the simplest possible security policy change. And this is something that you do not have to deal with much when you're working independently or you're working simply at an audit company. And but here, the devs are somewhat in contention with the security team always. They do not really like us a lot. I mean, probably it's just me, but whatever. So you have to be able to deal with that stuff and get to the result that you want. Like, if you want that, hey, the CI pipeline should have the static analyzer installed, then it should be there. Like, you need to figure out the non-tangibles, like who do I reach out to, when do I reach out to, how do I organize the meeting, who do I call to the meeting to make sure that this happens, right? Which is, again, a very non-technical skills, but it helps you get towards your technical goals. So make whatever of it that you want to. And yeah, the biggest challenge we face is how do we ensure that the 10x dev writes more robust and safe code without affecting their efficiency. Like, we do not want to kill this dev. Like, they have the one who have pushed the company farther than anyone. So we want to maintain their efficiency, we want to maintain the work rate that they have, but we also want to ensure that they do not push out reckless code. Just because they haven't done that in the past does not mean that they will not do it in the future. So that's, again, a challenge for us. Right. Web2 security challenges, this is pretty straightforward. All of us are working remotely. You are working, one person is in a remote village in Bali, one person is in Hawaii, one person is in Serbia. It doesn't matter. Like, everyone is spread out everywhere and everyone has laptops, and you do not know who has access to their laptop, physical access. You do not know which USB ports they are connecting their laptops to and stuff like that. So in that kind of environment, how do you ensure your Web2 security? So Yeah, and while the threat of a bug being discovered in our code always exists, another possibility is that of one of our core devs being attacked, like physically attacked. Their laptop and hard disk being stolen and stuff like that. How do you plan for that? Like this is very easy to ensure in a physical office. Like you're calling people into your office, you know that they come to the office, they have their office laptop, and that is what they do. But if you do not even know where they are or even what they look like, how do you ensure the security of the things that are present in their laptop? Another challenge. And yeah, managing this extremely sensitive infrastructure is completely remotely is no joke, and especially in a crypto environment where people value their freedom and anonymity a lot. They are not okay being monitored at all on their laptops, and to manage that with actual security threats is a big challenge. Right. So we'll go through this quickly. Okay. So I think the main task that we have is basically of prioritization. And why do we need prioritization? Because every dev and everyone in the company always has something on their plate. Like they are always doing something, they are always going to do something after they're done doing the thing that they're doing. So how do you get the authority to tell them that, hey, please drop this stuff and do what I'm telling you to do, because that's more important? How do you get that? That kind of authority you can only develop when you have an entire context on the entire company's development and you understand what are the business values, what are the business objectives, what are the current team emergencies right now, and you can align the resources according to it. Because the human resources are limited, it's always fixed, and people go on vacations, people fall sick, and that's not very reliable all the time. But the bugs are there and they persist. So how do you ensure that who gets where and solve the most burning problem? That again falls on the shoulders of the security team, that hey, we are counting on you so that you do not mess up royally and just save the company from a dumpster fire if it comes to it. And that is a very high stakes game, because any blow ups that happen because of something that we deemed of low priority is on us. So let me just see what the next thing is. Decentralized security is hard because, as again engineer talked about, that if you are talking about decentralized governance being hard, what about a fully decentralized network that discovers a bug in its circuits? How do you change that? How do you fix that? You have to fix that via decentralized governance, and that's again very hard because every person in the world can be a potential threat to you. And right, and amongst all this madness, you can never forget that you were meant to be a technical person, and you have to keep on upskilling and realizing what the devs are working on, and have sufficient knowledge in that particular domain so as to be able to detect and stop potential attacks from happening. So yeah, that's pretty much it from my end, and thank you.